Have you ever wondered if there could be another you living in a different world, making different choices? Imagine, just for a moment, a reality where an alternate version of yourself exists, engaged in a life shaped by different decisions. A world where what-ifs aren't hypothetical, but real. A parallel universe, if you will. A place where the road not taken is the road traveled. This idea might sound like a science fiction trope, but it's a serious area of study in some corners of physics. To begin with, what do we mean by parallel universes? Well, let's think of it this way. Imagine you're standing at a crossroads. Each path you could take represents a different potential future. Now, instead of just one of those futures unfolding, picture all of them happening simultaneously, but in separate realities. This is the basic idea behind parallel universes. Now let's take it a step further with multiverse theory. It's like you're not just at a crossroads, but in the center of a vast, limitless field with countless potential paths stretching out in all directions. Each path, each decision, each random event can give birth to a new universe. Like branches on a tree, these universes diverge, each creating its own unique story. But here's the twist. These universes aren't just theoretical possibilities. According to multiverse theory, they're just as real as the universe we live in, each existing in its own separate dimension. And what's truly mind-boggling is the sheer scale of it all. If multiverse theory holds true, there could be an infinite number of these parallel universes, each with its own laws of physics, its own history, its own version of you. So, in theory, there could be an infinite number of universes existing parallel to our own, each with its unique set of circumstances and outcomes. But how could these parallel universes come into existence? What does science say about this? To understand this, we need to delve into the realm of quantum mechanics, a branch of physics that describes the world at the scale of atoms and subatomic particles. Quantum mechanics is a bit like the Wild West of physics. Things can happen that seem to defy our everyday understanding of reality. One of the most intriguing principles of quantum mechanics is the concept of superposition. Imagine flipping a coin. In our everyday world, it's either heads or tails, right? Not in the quantum world. According to quantum mechanics, until you actually look at the coin, it exists in a state of superposition. It's both heads and tails at the same time. So, what does this have to do with parallel universes? Well, some physicists propose that for every possible outcome of a quantum event, there's a separate universe. This is known as the many worlds interpretation. In one universe, the coin lands heads. In a parallel universe, it lands tails. With every quantum event, the universe splits into parallel realities, each playing out one possible outcome. This idea extends far beyond coin flips. Every decision you make, every chance event in your life could lead to the creation of a parallel universe. In one universe, you might be a rock star. In another, you could be an astronaut. Now, you might be thinking, this sounds like science fiction, and you wouldn't be alone. The many worlds interpretation is highly controversial, and not all scientists agree with it. But it's also a theory that's taken seriously by many leading physicists. They argue that it's a natural and logical extension of the principles of quantum mechanics. While this might seem mind-boggling, it's an idea that is taken seriously by some of the world's leading scientists. So, is there any evidence for these parallel universes, or is it all just theoretical? As we delve into the world of evidence, or lack thereof, for parallel universes, we find ourselves in a realm of quantum mechanics and high-level astrophysics. Theories abound, but concrete evidence remains elusive. One of the most compelling arguments for parallel universes comes from the theory of quantum mechanics itself. Quantum mechanics suggests that particles can exist in multiple states simultaneously, only settling into a single state when observed. This has given rise to the idea of the multiverse, where every possible outcome of every event defines a different universe. But as intriguing as this concept might be, it's important to remember that it's just that, a concept. It's a mathematical construct, a tool used by physicists to make sense of the weirdness of the quantum world. It's not something we can touch, see, or measure directly, and that's where the skepticism comes in. Skeptics argue that without tangible evidence, the theory of parallel universes is nothing more than a speculative hypothesis. Some even go as far as to say that the multiverse theory isn't scientific at all, as it's not testable or falsifiable, key criteria for a theory to be considered scientifically valid. Then there's the controversy. If multiple universes exist, where are they? Are they beyond our universe, unreachable and unobservable? Or are they intertwined with our own, existing in dimensions we can't perceive? These questions stoke the fires of debate among scientists, philosophers, and curious minds alike. Yet it's these debates, these questions, and this skepticism that drive science forward. It's the constant quest for understanding, for evidence, for proof, that propels us into the unknown and pushes the boundaries of our knowledge. As of now, the existence of parallel universes remains a theory, but who knows what future discoveries might reveal? To sum up, the idea of parallel universes is fascinating, complex, and still largely theoretical. We've explored this captivating concept that suggests the existence of multiple, perhaps infinite realities running parallel to our own. This isn't a flight of fantasy, but a proposition grounded in scientific theories, such as quantum mechanics and the multiverse theory. We've delved into the science behind these concepts, venturing into realms that challenge our perceptions of reality. From the quantum realm, where particles seem to exist in multiple places at once, to the cosmological scale, where the multiverse theory suggests an infinite number of universes. Despite these compelling theories, concrete evidence remains elusive. Skepticism persists, which is a healthy part of scientific discourse. The search for empirical evidence continues, and the journey towards understanding is far from over. Whether parallel universes exist or not, contemplating them certainly opens up a world, or perhaps an infinity of worlds of possibilities.